Welcome back to the Handmade Hero macOS platform layer unofficial guide. My name is Ted, and I'm going to show you how to continue to develop the macOS platform layer for Handmade Hero. It's pretty fun. I've certainly learned a lot, certainly learned a ton about programming at a lower level. I would say that overall, it's kind of given me sort of a renewed enthusiasm for programming. So if you're kind of just starting, or maybe this is the first video you've seen, I would encourage you to start from the beginning because we get all the way up to this point. It kind of builds, and it's going to be pretty worthwhile, I would say. We're about to start getting into some really cool stuff, and we're actually like, it's kind of crazy. I get thinking, we're actually pretty darn close to being finished with this thing. Of course, we're never finished, but still, we're at what, platform independent file I/O now, and after that, it's just a few things, kind of like cleaning it up. There's going to be some really cool stuff taking the library and turning it into a dynamic library, which will let us do this really cool hot loading feature. And once that's done, I mean, that's it. So one thing. This is going to take a little bit longer, file I/O on the Mac, and a big reason that it's going to take a lot longer, or maybe not a lot longer, just a little bit longer, is because, well, the Mac is just, it's kind of an Apple thing, I guess, which makes a lot of sense. I mean, here's the thing, is like, you want it so that your apps basically run it in some kind of a sandbox. So, they're not touching memory that they shouldn't be touching. They're not touching parts of the file system that they shouldn't be touching. I don't really know much about Windows because I really haven't used a Windows computer in a long time. So I'm fairly sure that it's better now, but I could be totally wrong. But anyway, long story short, on a Mac at least, what I discovered while I was building this is I certainly can tell it, oh, just access this file at this folder, even if it's outside of the app. But what I found is that over time, it became, there were certain things that I wanted to do, like memory mapped file I/O memory mapped files in particular, and that is pretty much impossible if you're using a directory that's outside of your application's bundle, as it were. And similar actually for loading bitmaps, that kind of thing. So when you get later on in the series to like around day 40-ish or so, I think that's whenever it is that he starts loading bitmaps, if you try and load the bitmaps from a directory outside of the built applications directory, your app will just flat out crash. So basically, we've got a little bit more work to do than what Casey did, and what I want is for you to actually kind of get ahead of some of that stuff, so that later on when you encounter it, we're just going to be able to like load files kind of cleanly. We'll be able to do the memory mapped live loop editing without any issues, because the files will be stored actually inside the applications directory. So just with that said, the way that we're going to do it is a little bit more involved, because we actually have to find out where the app lives in the system, and then build up the file folder structure. So let's do that. And the first thing that we're going to do, I think, might make sense to just split this up into like 2 separate videos. So this first video, I think, is just going to be loading a file. So, first of all, we should, first of all, we want to figure out, okay, well, when do we want to even load one of these things, right? So, we come into our game update and render, and we've got this memory here. And I want to say that right at this initialization step is where we would want to, on the first frame, load something. So something like, we could just even do a to-do, like load a test bitmap here, right? And so the idea is, before any of our memory is initialized, this is where we would load it. We don't want to be loading bitmaps every frame for some pretty obvious reasons. You know, the system kind of takes a hit every time it's got to load a bitmap. So really, touching the file system is a very expensive sort of a thing. It's more expensive than just going out to memory. Used to be back when I was a kid, you know, in like the 90s. You know, all of our hard drives were like these spinning disk platters, super slow, and used to have games on like, you know, CD-ROMs or whatever, and you know, you're like, I remember putting Command and Conquer into my computer and like having the thing spin up, and so it used to be a lot slower. But the point being is like, what we're doing, again, I want to emphasize, this is not this is not going to be the shipping file I/O for the platform layer. What it's going to be is just a debug version, and obvious reasons. So one thing is, you know, in a shipping game, you would never load you would never load just individual bitmaps one by one for a lot of reasons. Main reason being that you don't want to repeatedly go to the file system. So what's more efficient to do is to do your own asset packing. So you take all your assets, textures, bitmaps, that kind of thing, and you pack it all together in a single file, and then you know beforehand what those offsets are inside of that file. That way, you're only going to the file system once. So you're only incurring that penalty of hitting the disk one time to get all that memory for your bitmaps and your textures. And then you just kind of have a thing that you can go through to find where those are. But for the purpose of just doing sort of like a rough sketch of a game engine, which is kind of what this is sort of a skeleton, just more of an exploration of what the game engine is going to be. We don't need to deal with those big problems yet. So we're kind of waiting to handle the official big file I/O. All we really want to do right now is just get kind of a really simple sort of file I/O in place and use that for the purposes of doing a skeleton kind of sketching out of a game engine. That's the idea. So we don't need anything super robust here. We just want something kind of to get us going. So that said, we know where we want to load the bitmap. And just as we had, you know, these structs for the off-screen buffer and for the sound buffer, we're going to do a similar thing for the I forget what exactly. Yeah, so we're going to call it a debug read file result. It's a good thing that my autocomplete has some of my work done for me. And all these things, you know, these debug sorts of functions, we only really care about having those defined if it's an internal build. So that's otherwise they're really not. We're not going to use them. So so internal build just for debugging purposes. We'll do that. And then what we want to do is so we're going to have just a void star pointing to the contents. And then I forget if it was a uint 64. Oh yeah, it was a 32. I mean, guys, this kind of doesn't matter if it's 32 or. And then we want the size. So all this is when we go to the platform, we're going to ask it for a pointer to its contents and something representing, you know, just a unsigned int representing the size of the stuff that we're getting. So that means we need a function to give us one of these debug file results back, right? And then we're going to call it debug platform read entire file. And then that thing is actually going to take a char star. And so just for the file name that we want to get. Another thing I want to check. Okay, yeah. So, okay. Yep. So we're this thing, this isn't returning like a pointer to it. It's just returning just one of them. So it's just returning an instance of the struct. Just so you know. So now that we've got this thing defined, we want to use it. And so we're going to go back down to our game update and render. And oops. We'll just say, pretending that we have some memory. Let's call it bitmap memory. And what we're actually going to do is we're going to read this thing called the test background .bmp. And what that is it just comes with Handmade Hero. It's some of the early artwork. So you're not going to have this unless you there you go. So there's another reason why you need to buy the game or pre-order the game is in order to get this test background, because you're not going to get any of the assets. That's how you get access to the asset files so that you can keep following the series. So yep. So we're going to do that. We're going to load. Read the entire file, and now that means that we need. Oops. That means we need to actually go and implement this thing, right? So somewhere in our platform layer, we need to implement it. So I'm going to say we're going to do that here. And this is where we start to get into kind of the territory of there's a lot that we're going to need to do kind of before we can even really get one of these things. And so I would say, kind of the first thing we need to do is we need to have some kind of a directory inside of the application bundle. So one is like make a directory inside the application bundle. Okay. 2, copy assets into that directory during the application build phase, whatever, just during the build. So whenever we build, we need to copy whatever our assets are. In that case, this is going to be that test BMP, test background BMP. And then we're going to need to do something like a make a path into the application directory with a resource subdirectory. And that's just for, we actually already have kind of like a resource. Wait, do we? I forget. We have something like this. But we need to modify our build process is basically what I'm saying. We need to modify our build process so that we're copying assets into like a directory inside of the application bundle that will hold on to our the files. And so then whenever we do a call into, and actually these aren't things that have anything to do with what's done inside of this. It's more like these are done outside of it. So, so we need these things taken care of before we can even really ever call this thing, because otherwise we're just not going to know what to even. We're not going to know where to get the actual files. So we have to create this path into the application directory with resource subdirectory, and grab our bitmap out of there. So definitely need to make some modifications to the build process before we can even start with this. So let's do that. So I'm going to open up my build script, and now we got this. So right now what we do is we make the bundle application, but then what we can also do is we can just add on to that, and so this will just create a whole directory structure for us. And I'm just going to call that the resources directory. So this is what we would call like the bundle resources directory. So that's actually inside of the bundle, and then it's inside of the resources directory. And then what we're going to do is we're going to yeah, so you see this already. What we have is kind of a local resource directory, this handmade / resources, and that's where our info.plist lives. So if I'm going back here and I look at this, so yeah, so even day 18. See this little resources? This is the resources directory that is kind of well, I guess it's not really cross-platform because it's got this info.plist in it, but the idea is it's supposed to kind of be a cross-platform directory, or rather that it's eventually going to be cross-platform. Maybe we have like a Mac resources or Mac, and then PC resources or like resources per platform possibly. But the idea is that resources are going to live in there. And so right now we're already copying this info plist from this resources directory into the application bundle directory, right? So handmade.app is the bundle directory. That's where this thing goes. Because remember, if I right click on it and go show package contents, just a little hint for everyone. Applications are not special. It's actually just a directory. So you go in the directory. So there's this directory and it's got my application and it's also got this info plist in it. What we want to do is we want to make it so that there's like a resources directory in here. And then that resources directory has our test background BMP inside of it. That's kind of the idea. That's what we want. So how do we do that? First thing I'm going to do is I'm going to go, I had that, so I have the legacy art. I'm just going to nab the test background, and then I'm going to go back so that we can do that. And let's see. I've got lots of these. Okay, so I'm going to throw that there. Okay, so now our test is to make sure that we can copy that test background, right? So copy this, and then so resources / test background.bmp, and then we want is like handmade app / resources, right? But see, now what's kind of interesting is you notice that we've got a little bit of duplication here because we've got this handmade.app / resources here and also here. So I would say this is a great opportunity to do a little bit of semantic compression. So what we're going to do is we're just going to pull that up into a variable. So I'm going to call that the bundle resources path, and that is this thing right here, right? Okay. And then all we do is we just reference that with $bundle resources path here. So now we're going to make the bundle resources path. And in the process of making the bundle resources path, it also makes the bundle path. So just so people don't get confused, like it's going to make this directory and then it's going to make this resources thing as the subdirectory. So now we've got this, and then yeah, so now this goes to the bundle resources path. So we got that. Oops. Okay. All right, and that's good, but also notice that we've got this too, right? So this is kind of copied, and we can definitely pull that out too. So we've got not only a bundle resources path. I'm just going to call it just the resources path because I'm not really, it's sort of the more generic thing. I don't know, if you wanted to, you could just put like a comment here saying, blah, 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 this is for the, I don't even know how to do comments on bash scripts. But I think, you just put a comment here saying, this is the resource path that's tied to the application bundle, and then this is just the one that's sort of like our cross-platform resource path. Okay. And then this is a little bit funny when you do, I don't know why, but Bash has this thing where if I do a variable inside of a string, I need to like enclose it in brackets. But either way, so we just resources path. Okay. All right, so now what we got to do, and now I'm just kind of thinking, do we have anything else that's, I guess you kind of have this, well, yeah, Handmade app. I don't really want to pull that out yet because that's, yeah. There really isn't anything else that needs to be kind of pulled up that's kind of used in a lot of places. I just don't like having like the same strings over and over again because these are really easy to screw up or like mistype, and you don't want to like you don't want to like have a bunch of places where you could make a mistake, and then anyway. So now we're gonna just build. All right. All right. All right, so we got an error. Yeah. Avoids. Oh, oops. That's right. Okay, so this, yeah. All right, so this warning we're gonna get. This is just a warning about how char star is deprecated. This first one here, from string literal to char star is deprecated. Like we'll do this later. We'll just ignore it because it's, I don't know. It's like a stupid thing. Like I should just be able to like pass a char star. I don't really care about that warning, but anyway. And then also, yeah, so this doesn't take a void star, it takes a debug file, read file result. So I need to change that in the handmade.cpp. So even though I've done this a ton of times, debug, read file result, file, read result. I don't know what to call it. Call it file read, something like that. This will be. It's kind of the same thing in Handmade Hero. So let's build it. All right. 2 warnings. Control reaches in. Okay. But the thing that we're not really looking at the code right now. We're actually looking at is when we built this. Does our application bundle now have our resources directory with the bitmap in it? And the answer, of course, is yes. So that's great news because now it means that we're inside of the sandbox, as it were. We can access our files in here, and that's great. So awesome to know. So we've got this part. Make a path into the application directory. Okay. So first of all, let's so starting this function, we need to make one of these things. Right. Okay. And then we're going to return the result at the end. And now, so getting the directory inside of the application bundle. There's a few things we need for that. One of them, I think, it's this. Got to remember what library it is. I want to say it's like, is it DYLD or something? I'm just going to keep this open because I've gone through this before. Yeah, I want to say it's this like mach-o DYLD. I don't know too much about the mach-o operating system, but we definitely need this for to get the executable path. And now we're gonna, it kind of makes sense to come up with some kind of like a structure that represents, here's what we want. We want some kind of something that like, and by the way, this idea is not mine. It's like I nabbed this from there's another guy in Utah that's like that had worked on one of these, and so I'm just nabbing his idea pretty much, which is terrible. But well, no, it's good. It's like Mike Oldham, that's his name. He and I have corresponded a little bit, but really useful stuff because yeah, he kind of came up with like a good sort of concept for sort of what a path needs to be on the Mac. And I want to say it's just so I think he just called it Mac app path. I think that's what I called it. Yeah. Yep. And that's got so it's just got a character array that represents the file name, and then a pointer to just one basically like I want to say that this goes to like right after where the bundle is located, and so that actually will help you when you're kind of appending the string onto the end, knowing where basically the start of the I'm not saying this that as good as I could be. Knowing right at the end of the character of the string of text that's going to represent the entire folder structure of where your application lives. So this is like one after that slash. So, and pardon me if this is like strings in C are kind of a pain. I think a lot of people sort of feel that way. So if this is not as explained as well, sorry. And then, so yeah, we'll also define this max file name size. And so just define that. I think it was like 4096 or something. So on a Mac, I think you can't actually have a file name that's longer than 4090, like I guess 4 kilobytes, which would seem to make a lot of sense. So anyway, yeah. So what we want to do is like we want to build one of these paths, and we want to build it like we want to build a path that is represents where our file name is going to be located inside of the application itself. So first thing we want to do is we want to say, okay, well let's make one of these paths, right? So let's Mac app path. Let's call it path, and then, oops. And then we'll say, all right, so we want something that, you know, we'll say it's an internal void, and then we'll just call it, I think I called it Mac build app file path. And then what this does is it takes a pointer to a Mac app path. Okay. And then just, so now what we want to do is we want to figure out, first of all, like where the heck is the application located. And I think we use this thing called ns-get bundle executable path or something like that. Okay. Yeah, this I had not. Okay. File name. All right, so this I'm kind of just going over this. So some size. So it's like the number of the bytes here, paths, file name. So okay. This part I haven't been as. All right, so build app file path. Well, that's interesting. So the file name part of this path is going to, oh, okay, wait a second. So yeah, well, this confused me because we're not setting the file name to anything yet, so that's strange. Oh, I get it. Okay, so at first, like, the file name is not set to anything, right? And then through the process, I'm sorry, I wrote that, like, I've been using this and I don't fully know what's going on here. So first thing, okay, so this buffer size is going to be, I want to say that's going to be 0, right? Because, oh no, just the size of the file name. Oh no, it's the size of the maximum possible. Yeah, file name is going to be the size of the max, so 4 kilobytes, I guess. So that's our buffer size at least. And then let's just read the documentation on this ns_get_executable_path function, because I feel like that's going to be a pretty important thing to know about. Get executable path. This is a little bit less polished than my usual. So let's see, ns_get_executable_path. This seems like it, but then, okay, so char buff. Okay, so that's the buffer of characters that is going to get filled up. So this thing is going to then, it's going to give us back a pointer to, I think it's going to fill up our buffer with the actual file name. UN32 star, okay, buff size. So, and we are passing the buffer size. So a lot of this is kind of defined by the API of this ns_get_executable path. Documentation isn't so great. No, here we go. Okay, so copies the path of the main executable into the buffer buff. The buff size parameter should initially be the size of the buffer. Okay, so in that case, like that for us is our. Hang on, I'm gonna copy this. Okay, and so yeah, so this buffer size is initially the size of the buffer, which is this max file name, which is 4 kilobytes. So I guess in the Mac we can't have more than like 4 kilobytes for a file name, which makes sense because that would be crazy. So we need to pass the size of this thing. So and that's the size that this ns_get_executable path is going to know. And then okay, so I guess this returns 0 if it was successful. So we'll take a look at that. This function returns 0 if the path was successfully copied. Okay, great. So we know that. And by the way, what am I looking at here? I'm looking at macOS manual page for the BSD library functions manual. This documentation is like really freaking old. Like, so a lot of this stuff is pretty hard to find nowadays, just so you know. But anyway, okay, so it returns 0 if the path is successfully copied, -1 if the buffer is not large enough and star buff size is set to the size required. Note that it will return a path to the executable, not a real path. What does that mean? Oh, that is the path may be a symbolic link and not the real file. With deep directories, the total buff size needed could be more than max pathlen. All right. I don't know what to think of that. Okay, and not a real path to the executable. That is, the path may be a symbolic link and not the real file. Does that matter? That's the real question, is does that matter? All right, I'm not sure if that matters. I'm really not. I don't know. I'm going to just put like a note here. Like, I actually just found that out, so I'm just kind of thinking to myself, just leave a note to myself. Not sure how this performs when the app directory is a symbolic link. So really no idea what the deal is there. So far, you know, in my testing and running it, you know, and then I guess the question is like, okay, if somebody were to install the app on their computer from the App Store, like, what would that do? Would that, you know, would that crash or not? That would be a good thing to know. These are all just kind of things we know. Okay, but assuming that this thing returns 0 for us and we find the actual executable path and we're all good, then what we need to do is we need to like figure out this what's the one path, you know, what's one past the app file name slash. It's like what's a location that is like right after that. So finding out where that is, or that particular pointer. So all we do is we start at the file name, right? And then we just keep scanning characters until we find a slash, right? And then we just add one more because we want to go one past that. And so that should help us figure out where the heck we are. So we're going to use that. So let's just like kind of run through this and test it and see kind of what we're doing here. We'll just pass a pointer to this path. Okay. And all we're going to do is just step through in the debugger. Just to see what these things do for us. So that's right, I need to set this up so that it will do that. All right. So I've got my Xcode. All right. And I know it's kind of annoying because I have to keep changing where this. I wish I could figure out a better system for this, because it's like every time I move the directory or something, I got to figure out where to put it. But at the very least, we have debugging, which is like pretty important. If you're just working on a project and you're not like doing all these videos, it's actually great. So it's just because I keep changing the directory and like moving stuff around that it does this. Right, and then I just want, files that where you want to start having breakpoints in there, you got to drag them into this folder structure. All right, so that's my cross-platform game library. That's great. All right, and what I wanted to do was put a breakpoint there and see what happens. See what does our path look like. Okay, we're going to launch. All right, so that was fast. All right, so let's find path. Oh, you've got to be kidding me. Where's path? Oh, that's not where I wanted to be. Right, okay, so it's got these. There we go. All right, there we go. Path. Wait, what? That's not where I wanted to be either. This makes no sense. All right, hang on. This is weird. What's going on? Why is my debugger acting this way? Okay. We've hit the breakpoint. Okay, what about here? Okay, what if I just... This is acting really weird. No, I don't want... I'm not there. What the heck? Alright, I'm pretty sure that, like, this is confused about what's where. Alright, so I'm just gonna remove that reference to that file, and I guess I'm gonna, like... Jeez, that was weird. Okay, so I'm guessing it's just that it had, like, the wrong file or something. No? Oh. That's why. Because it didn't build. Alright. 25 to... Oh. Well, that explains why my debugger doesn't work. Stupid! Alright, stupid mistakes. Okay, so now this is gonna, like, totally get us to our breakpoint. So this is an important thing to know is, like, if it doesn't build, your debugger is going to be off because the source code is not going to, like, this isn't a problem you would ordinarily run into, like, when you're debugging in other kinds of build environments, but when you kind of, like, when you sort of roll your own thing, you need to make sure that your app builds before you actually, like, start trying to debug it, because otherwise, like, the file that the executable that the debugger is attached to, the source code isn't going to match, like, your source code, and things are going to be, like, way off, and it's going to seem super confusing. So just, we're going to call this build app file path, and now we have this thing, and so this is where I wanted to look at right here. So, gosh, I would like to bump up the font on this. So what this is saying, character array, 4096 bytes. This is the full, full executable path, okay? And, well, actually, that's like, yeah. And so this is, this pointer is, like, right here in this. So that's what we want, right? Like, one past the file name slash, and that's printing out in my debug console as, like, the start. It's just going to print all the characters, because remember, in C, a string is, like, it's just a bunch of characters, and then it's got this, like, terminator at the end, it's got, like, a 0 at the end, and so it's just printing off as many characters as are after that. And so what we're going to end up doing is we're going to end up taking, like, this location here, and we're going to end up, if we want to access stuff that's inside of the bundle, we're just going to, like, write past it. So we're going to write like resources slash test background BMP, something like that. And so that's kind of how we're gonna do it. But so far, it looks like we were able to get the file name kind of for the application. So that's a big first start. And so that's good news. Again, like, I'm really not that great with string manipulation in C. I think I'll get better as time permits, but so far to me it's like, seems like one of those things where it's not as not as intuitive to me, and I think it's one of the reasons, like one of the motivations for some of the higher level languages is just kind of people realizing that string manipulation in C is just like a pain. So bear with me. So next thing we need to do is we need like some way to, so we've got this concept of like, we're passing in the file name. We're like passing in this like, you know, test BMP file name, test background BMP file name, and we want to be able to like slam that onto the end of the path, right? On the end of this thing. So that's kind of what our goal is next. And there's a few different functions that we use that I totally don't remember right now. So just gonna kind of go get those. But the idea, we're looking at, let's see, yeah, all of these we need, and I'm just going to walk through them. So we need a way to concatenate strings. This concat strings and string length, this actually comes, this is from Handmade Hero. So we need a way to concatenate strings. We need a way to like get the length of the string. And so we're just going to grab those. So this takes two strings and puts them together, as I understand. So you've got source A and source B and then a destination. So we're going to take whatever, okay, so we're going to start at 0, and then for as many as there are in source A, and then we're going to append source the source A, the first one, onto this destination, right? And then we're going to do the same thing with source B, and then this, all this does is it puts a cap at the end, remember, because the end of a string in C is just a 0. So it just goes, it goes, it goes till you hit 0. So this just ends it. I believe there's like a destination bounds checking kind of thing that we need to do here. So destination bounds checking. So need to bounds check this destination. But so far, I mean, yeah, I think this makes sense. Like we're just taking A and B and slamming them together, concatenating them, and then adding that onto this destination. And we're not even using the destination count. I think that just comes from it, where we might want to use it later for bounds checking, and then just to get the length of a string. So what all this does is like we'd have no count, right? Remember that a string in C is represented as just like a character pointer that has a 0 at the end. So if I were to do something like if I was to like say my name, like type my name or something, right? It would be each of these characters and then followed by 0. So it'd be like da 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 space da 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 da, and I'm stepping through each of these characters is like a byte, and so my byte pointer is advancing, and at the very end I put a 0 there in memory to just say, hey, I'm at the end of this string. And so all this is doing is it's going to start here, and then it's going to count until I hit 0. So I start at 0. I start at the beginning of the string pointer, and this while string plus plus or star string plus plus. So what that's doing is it's actually checking star string. It's checking because star string is the star in front of there. That dereferences the string pointer, and so what it's doing is it's actually checking the value. So it's starting off here and it's going, okay, that's a T, that's an E, that's a D, that's a space, that's a B, right? And then the plus plus at the end is just incrementing the actual pointer itself, right? So it's just taking taking this pointer and then like advancing it. It's advancing it along the string, right? And then if that if the thing that's dereferenced here is a 0, it's going to bail out of the loop and just return the count. So that's how this is kind of working. It's just, okay, starts here, 1, 2, 3, 4, 5, 6, 7, whatever, and then gets to the end. Oh, I hit a 0. Okay, well, 0 is really the same as false, so I'm going to just bail out of this loop and then return the count. So that's kind of how this how you could write a simple, string length function in C. And again, we're not, there's kind of fancier libraries. There's probably way more robust sort of string manipulation that we could do. We're not doing it yet, just because this is not a shipping platform layer. It is just something to kind of get you up and off the ground, like kind of making your own thing and being able to kind of experiment with some new ideas. So that's really what this is about. We're not trying to like solve the world's problems with respect to string manipulation at all. Like, we're actually just trying to get something that where we can like load some files. That's really it. So so now we're going to build the app path file name, and all that is just a big string concatenation. So we take our path that we got earlier, right? So remember that path we have it includes the executable path, but then a pointer to the place right after where right after that last slash for the directory. Okay, and then char star file name, that's the file that we want to load. So in that case, that is going to be our test BMP. So we want this test background BMP. Right, so that's the thing that we want to load from that bundled resources path, right? And then, yeah, then we want to pass in like a, probably don't need this desc count, remember, because probably not important because we're not actually using it. Or are we using it? We're passing it, but we're not doing much of anything with it. That's fine. And the destination is going to return our file name as it is inside of the application's path. So hope that makes sense. It's a big string concatenation. That's all this thing is. So we're just taking. So remember that one pass the. So we're calling this string concatenation, and we're passing first the source A is going to be one passed where the file name slash is. Okay, so that's A. That's the amount that we're gonna write for A. Oh yeah, because we don't want minus file name, path file name. That's saying this is how many bytes we want to write for the A part. How much is that though? Yeah, so we're going to write the whole file name. Oh, is that? Okay, yeah, so I think we don't want to write the entire contents of the directory plus the, I'm just trying to think how much that is. I mean, I get B. I get string B. So string B is going to be just the length of the test background BMP, right? And then we're going to just pass that in, and then the destination is just going to be, well, that's actually just like that's just a string pointer. That's like the result that we're going to get back. So this part, I'm a little bit less clear on. What that is, and honestly, like if we want to kind of like look into this a little bit more closely, what we can do is we can just since we know, right? So size t, right? So that's like number of bytes. We could just do this. We just say size t one passed at file name / size equals file name path file name size well, I don't know. Okay, no wait, that's not right. That's just taking never mind. It's just taking a location. Actually, I do want to just pull that out just to see like what the size is of that thing for A. I'll just call it file name size, path file name size. So some of this stuff I used and it's kind of worked, and then I haven't really looked at it too closely. It's just that I know that it worked well. I wrote some of the other stuff myself, or most of it myself. All right, so path file name size, and then we're going to concatenate that with, yeah, so that's the size. All right, I'm just kind of curious what that is going to look like. All right, we can step through that. So that's not, I don't want to get too hung up on that. And so now we want to kind of start making, we want to make this file. So I'm just going to use what we did there. Right. So I guess I called this like the sandbox file name, but we're doing kind of a, and I guess I could have done a, I used sprintf just to be able to take content / resources. Wait, why did I content / resources? All right. I'm actually just going to call this just resources. We could call it content / resources, I guess. But that means we got to change the build file. So I'm fine with that. So yeah, so now we're just adding this extra contents directory, that's fine. That's in our build. Okay. And so anyway, the sandbox file name is the final file name that we want, right? So I guess you could call that the bundle file name. Let's call it that. I don't like sandbox file name. This is like, yeah. I'll just make a note. This is the file location in the bundle. Okay. And we'll just call this bundle file name. Yeah, so that's the bundle file name. And then the local file name is, I call it local file name, but all we're doing is we're just concatenating this file name parameter that gets passed in here, file name here, to this other thing, contents / resources. So, and then so we're taking this thing here, right? This local file. We're taking the file name and adding it at the end of contents / resources. This %s, all it does is it substitutes the file name in at the end of this slash here. And then, so what we end up with, just so people know, we end up with content slash resources slash, say, test background dot bmp, right? So that's where we end up. That's what this does, right? And then that is actually going to be stored inside of this local file name. So then what we're going to do is we're going to use this app path file name thing to then take this thing right here, this content slash resources slash test background bmp, and put that at the end of wherever the app is in the app directory, the bundle directory inside the file system. So that's what this does. So, we want to call that bundle file name. Okay, I know that's kind of annoying, string manipulation stuff, but should be able to just kind of like put a breakpoint in and, okay, did we get any errors? No errors. Okay, good. So we should be able to just put a breakpoint in and then kind of follow that through. Yeah, and like I said, I would love to, kind of solve the world's string manipulation problems, but probably not going to happen. So here we are. So we stopped there, right? And what I want to do is like just look through here. I ended up coming up with a bunch of this stuff just stepping through the debugger. That's kind of how I got, how I figured a lot of this stuff out. Is just like, okay, what's going to work here? So remember, local file name was the thing that we wanted to. So we don't have a bundle file name. What we've done is we set up the buffer for it, and it's this Mac app path file name function that's going to build that for us. And then this local file name, that makes sense because we want it to be contents resources test background.bmp. And if I look at this this build directory here and I go and I show my package contents resources test background. So that we know is for sure in there. Like we've moved our bitmap into this test background into this folder, right? Okay, and so now kind of coming in here to this Mac build app pile, yeah, you get what I'm saying. So this was the part I was curious about, the path file size. Okay, 114 bytes. That must be like, what I'm guessing that is, okay, hang on. What I'm guessing that is like, that's the amount of bytes starting from like the very first, like, that's the amount of bytes all the way up to that slash, where the application lives. So that's the amount that we're going to take for our source A, right? Because source A in this string concatenation function is source A is like where the app is in the file system, right? And then source B that we're adding onto it is that content slash resources slash test background.bmp. Okay, and then destination is just like, that destination is like this empty string buffer that we're filling with all of it. So that's kind of how that's going. Okay, so we're gonna like concatenate those strings, and I'm gonna see that we got that. Okay, here we are. So this is a long ass thing here. Sorry for the children that I have cursed. User, Cedar Bendixson, app development, personal project, build handmade app slash content slash resources slash test background dot bmp. Yeah, and like I said, yeah, okay. And so here's this file name. Remember file name from path earlier, and then one past app. So we took file name. We took the amount of bytes that was, I think, right? Oh no, wait. We took one past file name slash. That's what I don't understand is this size here. Wait, size t is. Huh. Okay. Yeah, I'm still not sure why that file name size thing. I mean, we could step through it if we wanted to step through and like verify that this, that this is like 114 bytes or something to get here. I mean, what we do know is we know that we didn't write like handmade slash contents like here, because this is like the executable path. So I think what we like that ns get executable path or whatever, that gets like the executable, but we don't actually want the executable, right? Because like the executable is not interesting to us. What we actually want is like the bundle directory. We want the directory that the executable lives inside of, because that's where we're going to put our contents less resources slash test background .bmp. So there you go. Let's see. Time wise, we're at about an hour. I kind of think. Let's see. Yeah, so I'm going to say now is, oh gosh, OBS. Now is probably a good time to probably like wrap things up. I'm kind of thinking if there's anything else that I want to do, but I don't think so. So yeah, overall, what did we do today? We let's see. Did we make a directory inside the application and make a thing into there? Yeah, we did. Tomorrow's to do, and I will actually do this tomorrow, I promise. Actually load the bitmap. And there's a few other functions. So, and then we'll do to-dos. One is free file memory. That's going to be important. And then two is debug write file somewhere. And this is going to be, again, I think, reading and writing. Being able to write a file, that is also going to happen inside the bundle directory. One of the things that happens kind of later in the platform layer is we end up doing this thing where we do like looped live code editing, looped input. So as you're playing, you can record the input into the game, and then you can play it back over and over again. And to do that, we need memory mapped files, which means we need to be able to write to some files. But if you write to files that are outside of your application sandbox, the OS usually kills you, at least Mac OS does. So remember, a lot of the stuff that we're doing, kind of like figuring out where the application lives, is largely an Apple-specific thing, at least to my knowledge it is. Because Apple is pretty darn restrictive about where you can and can't access memory, where you can and cannot, which files you can and cannot load. You need to be loading files from your own little sandbox that they give you. So that's kind of what a lot of this is. So consider this kind of part one, and we will sort of continue with part two tomorrow. A few other things. All the source code for this will be available on the repository. And let's see. Yeah, so there's the full platform layer if you would like that. I have a link to that repository in the description. So, I mean, this is great, but right now you actually, for those joining, you actually have the full ability to follow what I've done and go and kind of make your own modifications. I've actually finished all of the code for the Mac platform layer, and there's actually a few other Mac platform layers out there. This is just to kind of give you a little bit of extra explanation, kind of walking through some of what it does and kind of why we're doing some of these things. So that's kind of what I'll tell you is if you want to kind of press on, you're actually not that far from the end. So you could press on, if you kind of follow some of this stuff. But I'm just doing the videos for people that are probably probably more new to C programming as I was, or just just straight C programming, whatever, and who really want to follow the series, but just kind of want more of a leg up on some of this stuff, more of a gradual introduction without having to like figure all of it out for themselves. So that's kind of what this is for. So also you can, I would suggest you go and buy a copy of Handmade Hero and support me as well. I have a Patreon, so be nice. Got a little money. Don't expect to make much money out of this, but it would be a cool thing if I could. So anyway, with that said, thank you very much, and have a good night. Enjoy making your game.